Good morning, all of you. So, I'm going to explain the concept of class diagrams and object-oriented analysis and design. So, in OOAD, there are several UML diagrams. UML means Unified Modeling Language. So, which is a visual representation of diagrammatic representation of all concepts in OOAD. So, it has several diagrams about static and dynamic diagrams. The first diagram is use case diagram, class diagram, interaction diagrams, state chart diagram, activity diagram, component diagram, and deployment diagrams. There are seven diagrams under UML. So here we are going to see about the class diagrams. This is the static UML diagram, one of the static UML diagram. Others are dynamic diagrams. So the class diagram illustrates the classes, interfaces, and their associations in the particular domain or in the particular area. Uh, they are used, so the class diagrams represents a static object modeling. So this is the representation of class diagram. It is made up of three parts: class name, attributes, and operations. So this is the common. This shows the notations used in the class diagram. So there are several notations used in the class diagram. So the class, this is the class, the rectangle represents the class and it is made up of three parts. First part is class diagram, second represents the set of attributes, and the third represents the methods of the class. And we are going to see several notations of the class diagram in detail, and we can represent the class as class as well as the interface. And there are several relationships can be specified in the class diagram, and the relationships are generalization, association, aggregation, composition, and dependency. And the relationships are shown with the symbols. Generalization is shown with the symbol straight line with the hollow triangle, and this shows the inheritance relationship, that is superclass subclass relationship between the classes available in the class diagram. So we can identify, we can determine several classes for the particular domain. For example, if it is a passport management system, so we can identify several classes related to the system. Like that, if it is a student information system, we can identify several classes. We have to determine several classes related to student information system. So the classes, the example classes are student, staff, management, college, department, library. Like that, we can identify several classes, and we have to specify all the classes, all the related in place software classes in the class diagram, and we have to specify the relationship between the classes using these set of relationships. The first relationship is generalization, so which is shown here, and which is used to specify the inheritance between the classes, that is superclass and subclass relationship between the classes available in the class diagram. And the second relationship is association, so which shows the normal association between the two classes. um, so there are several sub notations can be used inside the association, which we are going to see later. The third relationship is aggregation, which is shown using the symbol straight line and the hollow diamond. Aggregation and composition are the two part that is whole part relationships. So aggregation shows the uh, it is not a strong which shows the loose part of relationship between the two classes. Composition shows the strong association between the two classes. Uh, if the two classes are associated with aggregation relationship, for example, library and the book, and the book is a part of the library, so the if it is connected with aggregation relationship, if any one of the class does not exist, another class will exist. For example, if the library does not exist, the book will exist. So this is the example of aggregation relationship. But composition, shows the strong relationship, strong connection between the two classes. For example, the car and the engine. If we demolish the car, then the engine does not exist separately. So that is a difference between aggregation and composition relationship. The final relationship is dependency. So which shows the strong dependency between the two classes, which is shown using this symbol dotted arrow. So the dependency means if one class, if we change or if we perform any modifications in one class, it will affect another class. Okay. For example, the bank and the customer. So if we do any modifications in the bank, it will definitely affect the customer. So these are the example relationships that can be specified in the class diagram to provide the relationships between the classes. So there are several notations can be used in the class diagram. The first notation is classifier. So the classifier is the model element that describes the behavioral and structural features. So it can be specialized. So there are two special classes for a classifier. In class diagram, the two most classifiers are regular classes and interfaces. So we can specify the regular classes, also we can specify the interfaces. The next notation is attribute and association lines. So attributes can be shown in the second compartment of the class diagram, and the association line is used to connect to the two classes. So this is the example. Register and sale are the two classes. This is the association line which is used to associate the two classes, and how the classes are associated is specified by this association names. So this is the association name. uh, it can be specified at the end of the destination class, and we can specify the attribute text notation using three ways, that is association line notation, attribute text notation, and both. So this is the example for attribute text. So we can specify as a text, we can specify the attribute as a text. Example is current sale. So current sale is the attribute name, and this is the type of the attribute. Sale represents the type of the attribute, and we can show the same attribute name in the association line, that is end of the association line, current sale, or we can specify that same attribute in both attribute text as well as association line. So where specifically we need to specify the attribute text at the end means if the data type of the attribute is attributes specifies the class, or it specifies the object of the particular class means, then we have to we can specify the attribute in the association line of that class. So this is the representation of our syntax of specifying the attribute, visibility, name, type, and the multiplicity, and the properties string is optional. So what do you mean by multiplicity means? So here multiplicity is specified using uh, at the end of the association lines. The multiplicity can be represented at the end of the association lines. So it's so what it represents means, it represents how many objects of the particular class, the source class, is connected to how many objects of the destination class, and it can be represented 0, 1, and star. So if it is 0 means none of the object is associated with this another object. If it is 1 means only one of the object is associated with the another object. If it is star means multiple objects are associated with another object. So this is the example for multiplicity. And the role name can be specified at the target end. And these are the data types that can be specified in the attribute text. The attribute may be boolean, date, string, character, time, address. special security number, UPC, etc. So the association can be specified the using the navigability arrow, and it contains role name and it contains multiplicity, as I said earlier. And the property string is optional. The property string can be specified in the curly parenthesis. It may be the example for property string is altered or unique or list. And finally, the third compartment of the class contains operations or methods. And the syntax for specifying the operator is visibility name. It is visibility name of the class and the parameter list, colon, the return type, and the optional properties. Thank you.